My name is Chris Lee. This is Lambda Expressions and Generics. My student number is S2248178778. As a summary of the program that we're about to demonstrate, we are going to have some code that's going to be implementing a generic stack. We're going to be using the account class again, and we'll be creating account objects, and we'll add those to our stack. Once we have elements on the stack, we'll be able to interact with them through a number of methods defined in our myStack class. But to begin the tutorial, we will launch our debugger. Here we're creating an object of the myStack class, and we're defining our type T as account. So these are going to be a stack of account objects, and we're giving it a specified size of 10. Now we give it a specified size of 10 because the underlying storage for this stack is actually an array, so that's a fixed size. We can see here that we have a private array to store T objects. We've just declared that as accounts. We have a count property here with a public getter and a private setter. So for all intents and purposes, outside of the class, this will work as a read-only property. In any event, we'll go and initialize those. The count is at 0 right now, so we have no elements on the stack yet. Come down here, and we're calling the push method on the account stack object. Now this takes a parameter. It takes an account object, so we'll create one here. We'll give the name field a value of savings and the balance field a value of 100. So we'll go to the account constructor first. We'll associate those values there. Then we'll move to the myStack class. And in here we have the push method. Now we can see the parameter tval. So this is expecting an object val of type T. So this is expecting an account object. In here we have an if condition. Now first we'll check if the count is less than the length of the array. And what we're going to do there is just make sure we have space on the array to actually add an element or an object. And if we do, we'll assign that object at the current index of count, and then we'll increment count after that. This is going to allow us to keep adding consecutive objects to the stack without overriding them. Now I'll skip over these, but what we're doing is just adding more objects, so it's the exact same process. And after all this is said and done, what we have here is a stack where we're respecting the order last in, first out. So the last element we added is now at the top of the stack, and the very first one that we walk through is the bottom of the stack. Following that, we're creating an object of the account class called found, and the value or the object this is going to store will be found by calling the find method from the account stack object. And we're passing in a Lambda expression here. So this is an anonymous function. So on the left, we have our input parameter, which is going to be our object. And on the right, we have some criteria, and the criteria will evaluate true or false. So we are looking for an account with a balance of less than or equal to 100. Now this will go from the top down. So the first occurrence it will find is mortgage just here. So we'll move through that. Here's our find method. It's using the generic delegate again. So this is just saying that we're able to pass in some function. Now T is going to be the argument, the bool is going to be the result, and the criteria is just the reference variable. We have a for loop here, and what we're going to do is just say if the element at the ith index evaluates to true, once the expression has been evaluated, then we'll return the element at that index. It'll probably have to loop through about 3 times. Now in the event that it wasn't or it didn't find an element, it will return the default T. Default T is just null. Now null is going to be the value returned for reference types like classes and stuff like that. That's going to be our equivalent of or our 0 equivalent, if you will. We will find one though, so that's fine, and we'll return that. Now that we have that, we'll move on to the ternary operator down here, which is inside of the writeLine method. Now the ternary operator works as if, then, and then following the colon is else. So it's saying if found is not equal to null, which it's not, we'll evaluate then, and then the then branch is just going to print the value of the name and the balance properties. So we can skip over that. We don't really need it. The next thing that we do is create an object called found all, and this is an array that's going to store account objects. Now the criteria that we're searching for using the find all method is going to be any account with the name and credit. Now I will look at those, but I'll skip over stepping through it with the debugger. So we're looking for 2 accounts there. That's going to be credit there. For find all, what we do is the same thing. We have the same generic delegate there, so we're expecting an expression, which we just saw. We know the criteria won't be null. We'll create a list called results, and that will store objects of type T. We'll loop through, and we'll say if the element at the ith position of the array evaluates to true after we run that expression, then we'll add that to the array. For returning, we have another ternary operator, and we'll first check if the count of the results list is greater than 0, and if it is, we'll return that list converted to an array, and if it's not, we'll return null. Now, we'll find two matches there, so we'll move down here, and we'll say the object now has been converted, so that list has been converted, so we have two objects in there. So we're saying if that's not null, which it's not, we'll loop through and we'll just print the values of the name and balance fields. So I can skip through that. And then just to evaluate what I said was right, we can see the two accounts with credit popped up. Moving on here, we're actually going to be working on removing stuff. So this section here is effectively just for a little bit of context for myself. It's not actually necessary to removing elements off the stack, so I'll skip through that. But the way that was sort of working was I was trying to find out which accounts I wanted to remove that met the criteria of having a balance of less than or equal to 10. Now on the stack, we have 3 elements that meet that criteria. So it's the mortgage accounts that will be removed. They'll be added to a list, and then I'll just be able to print those out. The actual removal comes down here, but I'll skip down to that so we can see it. Okay, so we have an integer variable called removed accounts, and for that, we're calling the remove all method of the account stack object, and we're passing in that same Lambda expression that we were just using. I'll step in here. Now, the way that we remove elements in this program is by shifting left. So what we're going to do here is create an integer variable called I, and this is going to be the placeholder for the element that matches the criteria that we put in. So we'll come through here and we'll say if the element at the ith position matches the criteria, return true. That's going to be the element that we're going to be removing. To do so, we'll create an integer j, and we'll assign it that same value, and then we'll copy over the value of j plus 1 into j, and this is effectively going to move all of the elements left. And then once we've removed all those elements left, we'll just work on decrementing the total count, and that'll effectively cut off the elements there. That will return a value of 3. I don't know if we can skip through that. It doesn't look like we... Oh, it's going to let us. All right, not quite what I had in mind. Okay, now that we fast forwarded, we can see that the value of removed accounts was 3. I've skipped over that just now, but that does match the accounts that met the criteria, which was a balance of less than or equal to 10. Now, the next thing that we're going to do is come down here and create an object called min account of the account class, and we're going to call the min method from the myStack class, which is on the account stack object. And the min method is down here. And so what we're doing here is first we're checking if the count is 0. So if the stack has no elements, we'll return null. And if it doesn't, we'll move on. We'll create an object of the comparer class called comparer. And all we're going to be doing is using the default comparer. Now, the default comparer relies on the iComparable interface, which we've implemented into the account class. Now, for the iComparable interface, we've defined a public method called compareTo, and this is going to define how we're comparing account objects. So it will let us compare them by balance, and say the balance of account object 1 was greater than the balance of account object 2, then we'll return 1, but we can return for a number of different cases. For minimum, what we'll do is we will set a minimum of type t, so it's going to be an account object here is the minimum, and that's going to be assigned to the 0th position of the array. We're going to go through and we're going to call the compare method from the comparer object. Now this is going to use compareTo, which we defined in the account class. And from there, we just want to figure out if the current element at the ith position is smaller, has a smaller balance than the element assigned to min, then we'll just reassign that current element to min, and we'll go from there. Now, once that does, if we have a minimum account, what we'll do is we'll return that with a name and a balance, and that will be the account on the stack that has the smallest balance out of all the elements. Down here, just to sort of conclude some of my testing, I've created 2 account objects called account 1 and account 2. Now, these are separate from the stack. These are just their own individual objects. And I've given account 1 a balance of 100 and account 2 a balance of 50. And then I've moved on down here, and I've called the compareTo method. So I'm using account 1, I'm calling the compareTo method, and I'm checking the passing in account 2, which means it will come in here. So the left side of the operator will be account 1, and the right side of the operator will be account 2, just for some context. But what we'll do is we'll move through there, and we'll get the balance value for both of the accounts. Now, we know that account 1, sorry, I've gone to the wrong tab. Account 1 actually has a balance that's greater than account 2, so we'll not execute that first line there. It'll move down to here and we'll evaluate that. We'll probably need to get the balances again. Yep, which we do. And then we'll return 1 from there. So that's a sort of demonstration of how that compare to method works from the account class. Thank you.